Okay, we're going to wrap up our factoring section. Factoring involving fractional and negative exponents. Even though these expressions are not polynomials, they are not polynomials, they can still be factored. Really, these are all about taking out the GCF. Now remember, you can't take anything large out of something small, but you can take something small out of something large. So looking for the GCF, you're looking for the smallest exponent on the same base. Because remember, again, you can't take something big out of something small. So you're looking for the smallest exponent. That's the clue. It is the greatest common factor because it's the biggest thing that can be pulled out of each factor. Sometimes it's just an x, and sometimes it's a quantity involving x. And so if I look at this example here, I look and I say, well, this term separated by addition to this term, they each have an x minus 1 quantity in common. But this one has a negative 1/2 power, and this one has a positive 1/2 power. Which tells me, if I know my positives and negatives, this is the smaller exponent on that same base. So what I'm going to do is write the GCF on the left side of the plus sign. I'm going to copy the plus sign, and I'm going to write the GCF on the right side of the plus sign. Now I have to compare step 1 to step 2, okay, the given problem to our first step where we're factoring out. And I compare, is this term the same as this? And you say, well, no, because what about x? Well, you need x. This was my GCF, and I see the GCF here. So I'm done right now with rewriting. This is the step where we're rewriting. Over here, though, this has changed from x minus 1 to the positive 1/2 power to x minus 1 to the negative 1/2 power. You need to multiply by the same base. And you could either think of it this way. What do I add to negative 1/2 to make it be a positive 1/2? Or you can subtract exponents because we are dividing. 1/2 subtract negative 1/2 is really 1/2 plus 1/2, which is 1. Okay, so from going from here to here, it's subtract 1/2, subtract negative 1/2 is 1. Or, property of exponents with multiplication, you add the exponents, is negative 1/2 plus 1 positive 1/2? It is. Now I'm ready to factor out my GCF. And my GCF is quantity x minus 1 to the negative 1/2 power. In brackets, I just use brackets instead of parentheses because it gets too much parentheses involved. And then you don't know where the grouping symbols are. So remember what I said before. Factor means divide. So if I take the product of these two items and divide it by this, these are going to divide out, leaving me with x. So I put x right here. The sign is addition. And if I factor or divide out the GCF from this product, I'm left with a quantity x minus 1. And technically that's a quantity. It's not really going to matter when there's plus here, but when there's a subtraction sign there, it is going to matter. So I usually just group it anyway. So what do I have? X minus 1 to the negative 1/2 power multiplied with x plus x minus 1. What's in this grouping? You have to simplify this. You can't leave it like that. So I write another step, x minus 1 to the negative 1/2 power. X, add another x, is 2x minus 1. Now, there's only one last thing to do, and that's called simplify, which we did right here in this step. Expressions are not in simplest form if you have any negative exponents. So I have to put this base with that exponent in the denominator. So I end up with 2x subtract 1 over quantity x minus 1, and yes, I need the parentheses, to the positive 1/2 power. Remember, this quantity to the 1/2 power is really the square root of quantity x minus 1, so you do have to group it. Okay, so what did we do in this step? We did a rewrite. In terms of the GCF. Okay? So we took the original problem and we wanted to actually physically see the GCF. What did we do in this step? We factored out the GCF. What did we do in this step here? Well, we were simplifying. What did we do here? We simplified again. We added the x's. And what did we do here? We also simplified. So simplify using properties of exponents. Okay, these aren't that too terrible if you learn the algorithm. And once you get a feel for it, you're never going to forget it. Okay, let's try the second one. Excuse me. These two terms, separated by addition, do have something in common. They have a base of x squared plus 3 in common. The exponents are different. You need to ask yourself, which one is smaller? You might think 2/3 is smaller than 5/3, and if they were positive, that would be true. But this is the one that's smaller. Remember, if I had something like x squared plus x to the power of 1, I can only take a single x out. That's the smaller exponent. It's the same thing here. Okay, so GCF here would be just a single x, and then you'd be left with an x plus 1 for an example like this. It is the smaller exponent. Okay, the next step is copy. I'm going to put the plus sign. I like to do that kind of first. And then I copy the GCF on each side of the plus sign. So the GCF is negative 5/3. And I'm just copying it on the left side of the plus sign and the right side. Now I'm going to compare. Is this equal to this? And you say, well, no, it's not. And so since it's not, I'm going to have to subtract the exponents. Or ask myself, what power on the same base do I add to this one to get that back out? Negative 2/3 subtract negative 5/3 is negative 2/3 plus 5/3, which is 3/3, or 1. This isn't always going to be a power of 1, so that's why I'm writing it as 3/3. Here's my plus sign, and this term is exactly this, so you could do times 1. That sometimes helps as a nice visual. Now I'm ready to factor out my GCF. The GCF is x squared plus 3 to the negative 5/3 power. What's left inside? Well, factor means divide. This is going to get divided out. This has to go in the quantity. And since it's power 1, and it's positive here, I'm not going to distribute a negative. I can leave the grouping symbols off. This is x squared plus 3, this quantity to the power of 1, plus. Now, when I divide this product by the GCF, I'm left with 1. 2 steps left to go. I've got to simplify inside the grouping, and then I have to move this to the denominator. So once you get the hang of doing these, you can move that to the denominator in the, one step. But just for notes, I'm going to show that it really is 2 separate steps. X squared plus 4, that quantity divided by quantity x squared plus 3 to now the positive 5/3 power. Okay, and they come with a little bit of practice, but you do have to practice and doing the homework. All right, there's nothing on this side, but I do have a second note sheet, which kind of like brings this together, maybe a little bit of a structured algorithm, if you will, for helping you to factor these rational and negative exponents. First thing you want to do is identify the GCF. And remember, that's the smaller exponent. I would copy the signs down. Sometimes you have more than 2 terms. So I would copy any signs down between terms. Then you rewrite each term in the expression in terms of the GCF, which means I want to physically see the GCF. If you've ever seen those problems in geometry, write your answer in terms of pi. That means they wanted to see pi in the answer. So if I'm rewriting my expression in terms of the GCF, that means I want to see the GCF in each term. Remember, this expression has to be equal to the original one. Like back in this part of the notes, I changed this to a negative 1/2. I must multiply by some power on that same base in order for this multiplied with this to equal the original. This step and this step are exactly equal to each other. And that's what this means. And then you must recall the property of exponents. Okay, factor means divide, and when you're dividing, you subtract exponents. Or when you have a product, you add exponents. We're going to write the GCF in front of an open parentheses. And then you're going to divide each term in the expression by the GCF and write the result inside the parentheses. You then simplify both inside parentheses and any negative exponents. Okay, so simplify the inside of the grouping and then move negative exponents to the denominator. So really these 2 steps are my simplifying. Recall a basic GCF factoring problem. Factor 4x squared plus 6x. We really do, in our minds, think about what the greatest common factor is. 4 and 6 are even. The only number that divides them, the greatest number, the biggest thing I can take out of each of those, is a 2. This has got an x squared, this has got an x to the power of 1. I can only take a single x out. That's the greatest thing that can be factored out of both. I could think of rewriting this so that I can physically see the GCF. So I could do a 2x here, copy the sign down, do a 2x here, and then I ask myself, well, what do I multiply with 2x to get 4x squared? Well, that would be another 2x, because 2 times 2 is 4, x times x is x squared. This was my GCF. And then what do I multiply 2x by to get it to be a 6x? Well, you can think of it as division. 6 divided by 2 is 3. X to the 1 minus 1 power is x to the 0. Or I could say, what do I multiply 2x by to get a 6x? Well, that's 3. Again, this is my GCF. So I move the GCF out front. Factor means divide, so when I divide this out, I'm left with 2x. And here's my plus sign. And when I divide this term by the GCF 2x, I'm left with 3. It's the same algorithm. Same algorithm. All right, 2 more examples. And then I want to show you something that could possibly be a bonus on a test or a quiz. All right, so factor. 2x to the 4/5 power, subtract 10x to the negative 1/5 power. I have to identify my GCF. So over here off on the side of my paper, I'm going to say the GCF is, I have a numeric component this time, 2, and x to the, well, negative 1/5 is smaller than positive 4/5. So that's my GCF. 2x to the negative 1/5 power. I'm going to copy my sign now. It's subtraction. I'm going to put the GCF on the left side and the right side. And now I'm ready to divide, if you will. I don't need any coefficient here to multiply because 2 divided by 2 is 1. This I'm dividing, so I'm going to subtract. This becomes x to the 4/5 subtract negative 1/5 is 5/5. And if I do a check this way, it's add. Negative 1/5 plus 5/5 is 4/5. So I'm convinced this is equal to that. There's my subtraction. Now, 10 divided by 2 is 5. And now this divided by itself is 1, so I'm done. It's just 5. This and this, those are my GCF on each side of the subtraction sign. Now I'm ready to factor it out. 2x to the negative 1/5 power. Got a parenthesis. This is getting divided out. What's left? X. Subtract. This is getting divided out. What's left? 5. Now I do have one problem because I do have a negative exponent. And you need to be careful that you understand the difference of when there's parentheses around a product raised to the negative power and when there's not. Only x is being raised to this negative power. Only x. The 2 has to stay up in the numerator. So that's got a positive exponent of 1 here. Understand? So it's got to stay up. So it's 2 times the quantity x minus 5 divided by x to the positive 1/5 power. Okay, so be careful. This is a common mistake students make. They want to take the 2 down with that. It's not attached to it unless there's parentheses around it. And one more. Factor. Well, I have to look for a GCF. My GCF, I could take a 4 out of each. And I do have a quantity x plus 3. And I'm looking for the smaller exponent. That would be that one. A negative is always smaller than a positive, so negative 2/3. I'm going to copy my sign down between the terms, and I'm going to write my GCF on each side. Or x plus 3 to the negative 2/3. Then I do a comparison. Or actually, it's like I'm dividing out my GCF. 4 divided by 4 is 1. This is not the same as this. So now I'm going to subtract exponents. 1/3 subtract negative 2/3 is 3/3. check it. When I add those exponents, do I get that? I sure do. Over here, this is the subtraction sign. 8 divided by 4 is 2, so I have to put the 2 back in. Remember, because I have to keep this equal. 4 times this times 2 is really 8 times this. And this is itself, so I'm done. I don't need another quantity x plus 3 to any power. Now I'm ready to take out my GCF. 4 times quantity x plus 3 to the negative 2/3 power, multiplied with, well, what do I got? This is going to divide out. That's going to divide out. I'm left with this, x plus 3 to the power of 1. I don't need grouping symbols there because it's positive in the front. All right, my sign is subtract. 4 times x plus 3 to the negative 2/3 power. So I'm going to say this is going to get divided out, and I'm going to bring the 2 down. Sometimes you'll have another quantity here, and when it's subtract, you will have to distribute, so be careful with that. All right, what goes to the denominator? Only quantity x plus 3. So the 4 stays up. You can move that to the denominator right away. The exponent's going to go positive. And now I've got here x plus 3 minus 2, which is going to end up being quantity x plus 1. And I'm done. So if you have any questions on that, post a comment on the homework discussion, and we'll see how you do with that. Now, one other thing that I do want to show you is this idea of factoring the difference of squares when the exponents are large. And I know this is difference of squares because any exponent to an even power is a square. Okay? So like x squared is a square. The exponent is even. Well, a to the 12th is a square, and so is b to the 12th. Not only that, but this could be thought of as a difference of cubes, because 12 is divisible by the index 3. But I highly recommend when you have even exponents and it's taking on the difference of squares, I would factor it in terms of squares first and wait for the cubes later. I'll show you the difference between the two. When I rewrite it so that I can physically see that it is the difference of squares, okay, that would be a to the 6th raised to the 2nd would be a to the 12th. And b to the 6th raised to the 2nd would be b to the 12th. So remember how dots factors, it's a plus b times a minus b. So this would end up being a to the 6th plus b to the 6th times a to the 6th minus b to the 6th. And there I have that. Now we're not done because this is still dots and this is the sum of cubes. I know they're cubes because 6 is divisible by 3. And so in the next step, here's where I just showed and illustrated that this was cubes, right? A squared cubed is a to the 6th. And then over here I did the same thing. I divided the exponent by 2 for square root. This is a cubed squared is a to the 6th. So this I set up as difference of two squares, and this one I set up for sum of cubes. You've got to know the formulas of how cubes factors. Okay, so I had it was a plus b, which is a squared plus b squared, and then you had to square this to get a to the 4th. You had to square this to get b to the 4th. And you just multiplied these together and changed the sign. That's how the sum of cubes is going to factor this. This here is going to be a cubed plus b cubed times a cubed minus b cubed. But we're still not done. Remember, this trinomial can never be factored in the cubes. This is the sum of squares. That's SOTS. So this is done. This part's done. But this isn't. I've got the sum and difference of cubes. And so I've got to do another step. This I just copied because it's part of the answer. This sum of cubes is going to factor as a plus b. And then remember, you got to square this, and then multiply them together and change the sign. And then for the difference of cubes, it's a minus b because of the sign. And you square this and square this, multiply them together and change the sign. You could then take one last step and just rearrange it to put your binomials first and then your trinomials. So a longer factoring problem, maybe one that you have not seen before. Now, what would this look like if I were thinking of this as a to the 12th minus b to the 12th as cubes? Well, I'm going to tell you, it's a lot longer. Okay, so I'm just going to show it to you. Don't get scared. I'm not going to ask you to do this on a test, but you should know that it exists. If I thought of this as cubes first, then that would factor as such. Right? A to the 4th cubed is a to the 12th. This is going to leave me, well, now I'm factoring cubes, so it's going to be a to the 4th minus b to the 4th, and then I have to square this, multiply them together, and then change the sign. This part here, this is dots, so I set it up as to be the difference of square. A squared squared is a to the 4th. This here, though, this can never be factored, but I can manipulate it. You see, if I add 2ab to a to the 4th, b to the 4th, and then subtract 1 out, okay, 2 of these minus 1 of those is 1 of those. So I can rewrite it. Because remember, we just factored this, and it ended up being 3 binomials times 3 trinomials. And this is going to be a factor by grouping then. Okay, let's see what happens in the next step. Okay, here's my dots, a squared plus b squared times a squared minus b squared. And I'm going to group 3 and 1. Okay, I wanted this subtraction 1 on the end by itself, because I want to set this up to be dots, right? A squared, b squared, that product to the 2nd power is this term right here. And when I factor this, this is a perfect square trinomial. So what did I do in this step? Well, let's look. I can never factor sots. This is dots. This is a perfect square trinomial. So this now is the difference of 2 squares. That's going to factor as a plus b times a minus b, where a to the 4th plus b to the 4th is my a, and a squared b squared is my b term. And so now when I look at it, I'm going to do that trick again. You know, as long as, excuse me, you have the plus on that end, you can do this. Alright, so I've got 2 of those, and I'm going to subtract 1 of those out to keep it equal with that. This one, I couldn't do anything with this one. This is actually, you know, quantity a to the 4th plus b to the 4th minus a squared b squared. Let's see what happens next. None of this could be changed because this was factored down to its prime. Here is my dots that came from this. Okay, this thing I just copied. None of this changed because it's prime. This is dots. That's going to factor like this. And there's nothing much I can do with this piece right here. So I just keep it. Now, I just simply recopied it without these grouping symbols. And if we look and compare to the much shorter way, excuse me, of factoring this, I'm going to fold my paper so that we can see that the last line on the first example is in fact equal to the last line on the second way I've done it. So why am I showing you this? Well, to show you that if something does take on the form of the difference of cubes and the difference of squares, it's going to be so much easier to approach the problem as a difference of 2 squares first. Okay, so Hopefully you enjoyed that large factoring problem and the way we can manipulate a polynomial so that we can get it to factor. If you have any questions on the factoring of the rational exponents, again, please ask when you're in class or on Google Meet, or those are for the online learners, or post the question on the homework discussion. Have a great day.